The chimney standing quiet on top of an old house is easy to overlook, but for centuries it did far more than vent smoke. Long before air conditioning existed, builders used a simple principle of physics to keep homes comfortably cool through the hottest months, and that same principle is tucked inside many older homes today, waiting to be rediscovered. It's called the stack effect, and understanding it could change the way you think about your own home's ability to breathe. Warm air rises. That single fact is the foundation of an entire cooling system that requires no electricity, no compressors, and no monthly utility bill. In a traditional solar or thermal chimney, hot air trapped inside a home rises up through a vertical shaft. As it escapes through the top, it pulls cooler air in behind it from lower, shaded parts of the house, often through basement vents, cellar doors, or windows positioned near ground level. This creates a constant, gentle current of air movement that flushes heat out of the living space and draws in cooler replacement air. It is essentially a passive form of ventilation that mimics what a fan does, except it is powered entirely by temperature difference and the natural tendency of hot air to rise. Homes built before the mid-1900s were often designed with this principle in mind, whether or not the builders used modern scientific language to describe it. Thick masonry chimneys absorbed heat from the sun during the day and created a strong updraft as the air inside the flue warmed. Many farmhouses and colonial-style homes across North America included tall central chimneys, specifically because they helped regulate indoor temperature year-round, not just because they vented fireplace smoke. In warmer climates, similar designs appeared in the form of wind towers and roof vents that worked hand in hand with chimney flues to create cross-ventilation throughout the home. If your house has an older chimney that is no longer connected to an active fireplace, there is a good chance it could still be functioning as a passive cooling channel, even if nobody in your household realized it. This is one of the most overlooked features in home energy efficiency conversations today. While homeowners spend money upgrading insulation, replacing windows, or installing new air conditioning units, the answer to noticeably cooler summer afternoons might already be built into the walls. So how do you know if your chimney is contributing to passive cooling in your home? Start by checking for airflow. On a warm day, hold a lit incense stick or a strip of tissue paper near the base of the chimney opening, whether that's a fireplace damper or a vent connected to the flue. If you notice steady movement of smoke or paper being pulled upward, that indicates the stack effect is active and air is being drawn through the chimney shaft. This single test can reveal whether your home has a built-in cooling mechanism that has simply gone unnoticed for years. Reviving this old system doesn't require a full renovation. If your fireplace damper has been sealed shut for energy efficiency reasons during winter, consider opening it strategically during summer afternoons and evenings when outdoor temperatures drop. Pairing this with open lower-level windows on the shaded side of your house creates a complete airflow loop. Cool air enters low, warm air exits high through the chimney. This cross-breeze effect can lower indoor temperatures by several degrees without touching your thermostat. Homeowners looking to maximize this effect should also pay attention to timing. Passive chimney cooling works best during the early morning and late evening hours, when outdoor air is cooler than the air trapped inside the home. Opening vents and windows during these cooler windows, then closing them again once outdoor temperatures rise past indoor levels, helps trap the cool air you've captured and prevents hot daytime air from being pulled in and undoing your progress. This kind of manual airflow management was standard practice in homes for generations before mechanical air conditioning became widespread and affordable. Another important factor is the color and material of your chimney's exterior. Dark-colored masonry or metal chimney caps absorb more solar heat, which actually increases the temperature difference between the air inside the flue and the air inside your home, strengthening the stack effect. This is why many historic chimneys were left as exposed brick or stone rather than painted with reflective coatings. If your chimney has a metal cap, make sure it is not blocking airflow with debris, nests, or rust damage, since a partially blocked flue significantly weakens this natural cooling process. For homeowners without a functioning chimney, it is still possible to borrow the same principle using modern adaptations. Solar chimney kits and small rooftop turbine vents mimic the exact stack effect mechanism using a small vertical shaft designed to channel rising hot air out of an attic or upper floor. These additions are relatively inexpensive compared to running central air conditioning and can meaningfully reduce indoor temperatures, especially in homes where the attic traps heat and radiates it down into living spaces below. It's also worth understanding why this old-fashioned approach still matters in an age of advanced HVAC systems. Air conditioning units consume significant electricity, contribute to higher utility bills, and place strain on power grids during peak summer demand. Passive cooling methods like the chimney stack effect don't eliminate the need for air conditioning entirely, but they can reduce how often and how hard your system needs to run. Even a 5-degree reduction in indoor temperature through natural airflow can translate into real savings over the course of a summer, while also reducing wear on mechanical cooling equipment. Beyond energy savings, there is something valuable in simply understanding how your home works. Many homeowners live for years without knowing why certain rooms stay cooler than others, or why opening one window seems to make more of a difference than opening several. Airflow patterns tied to chimney placement and stack effect principles often explain these mysteries. A room located near the base of an active chimney draft may consistently feel cooler, while a room isolated from that airflow loop may trap heat regardless of insulation quality. If you're considering renovations or additions to your home, this is worth factoring into your planning. Sealing up an old chimney completely for aesthetic reasons, or replacing it without considering its ventilation role could inadvertently remove a passive cooling feature your home has relied on for decades. Before making that decision, it may be worth consulting a chimney specialist or energy auditor who can assess whether your flue is contributing meaningfully to indoor climate control. For those who want to take this further, combining chimney-driven airflow with strategic landscaping can amplify the cooling effect even more. Planting shade trees on the sun-facing side of your home reduces the amount of solar heat absorbed by your walls and roof, which lowers the overall temperature of air entering your home through lower windows and vents. This cooler intake air, combined with the natural draft created by your chimney, creates a more powerful and consistent cooling loop throughout the day. Ultimately, the chimney that many homeowners view as an outdated or purely decorative feature may be one of the most functional elements left in older home design. It represents an era when builders worked with natural forces rather than against them, using heat, air pressure, and material choice to create comfortable indoor environments without electricity. Rediscovering and maintaining this feature isn't about rejecting modern comfort. It's about reducing dependence on mechanical systems and lowering your energy costs while making your home more resilient during power outages or heat waves. Next time you look up at your chimney, consider that it may be doing more work than you realize, quietly pulling heat out of your home and keeping things comfortable using nothing but the natural behavior of warm and cool air. Taking a few simple steps to understand, test, and optimize this feature could be one of the easiest and most cost-effective home improvements available to you this season.